With question number 5. So it's about union and intersection of the sets. So very first part is if cardinality of one set is 5 and cardinality of second set is 9. So let's call these sets A and B. First of all, what is cardinality? Cardinality is size of the set. How many elements are there in the set? For example, if we have set A, B, C. So what is the size of the set? It's 3. Our cardinality of set A is 3. So notice this symbol. We use these two bars to represent size or cardinality of a set. Fine. So in question it is given we have two sets. One set has size 5, the other set has 5, 9. What could be the size of their union? What is cardinality of their union? So just see what possible cardinalities of A union B could be. One extreme cases, look at the extremes. Extreme. There's no intersection. They have no common element. No common element. Both sets have no common elements. So if we take union, so all elements of A and all elements of B will come in the union. So it's obvious what will be the size of union. And if we have some elements common, so we will count those elements only one time. So what is the extreme case? Extreme case will be if smaller set is complete subset of larger set. Smaller set is completely contained in bigger set, completely contained in larger set. So obviously in sets we cannot repeat any element. So if we take union A union B, what will be the size of A union B? It will be the maximum among A and B. So A is smaller than B, so B is maximum, is larger. So in this question A union B, their cardinality is greater than max of A and B. Among A and B, whatever has maximum size. Of course, it's 9 here, so instead of max AB, I just write down 9. And it should be less than sum of their cardinalities, means cardinality of A plus cardinality of B, which is 9 plus 5, so I just write down 14 here. 9 plus 5, which is 14. So union of set, possible union of sets, possible sizes of the union is between 9 to 14. So in this question, we can see possible sizes could be 9, could be 10, could be 14, or anything between 9 and 14. So 20 is not possible, 6 is not possible, 4 is not possible. Fine. Part B is just generalization of part A. So in part B, they say if size of set A is M and size of set B is N. So what will be cardinality size of A union B? We have just solved it. So in extreme case, if no common element in A and B, so in that case all elements of A and all elements of B will come in the union. So A union B set will be maximum M plus N. And on the minimum side, how could be least possible size is whichever is maximum of M and N. So A union B is equal to max M N, whichever is maximum in among M and N. So instead of equal, I just put less than equal to. The A union B size could be less than equal to M plus N, and A union B size could be greater than equal to maximum of Mn. So we define a range. A union B size is greater than equal to max of Mn and is less than M plus N. Fine. So we define a range for the cardinality of A union B. So let's move to part C. It's about intersection of sets. So we have given 3 scenarios. There are set 0, 1, 3 and 1, 2, 3. We have to find common elements. So it's simple. I will not explain this thing. So second scenario, the set of girls in the class and set of boys in the class. Obviously there is what is common you can think of. And the set of prime numbers and the set of even numbers, you know what are even numbers, 2, 4, 6, 8, 10 and so on. And what are prime numbers? 2, 3, 5, 7, 11, 13, 17, 19, 23, so on. So you can see which one is common element. Let's move to part D. So it's similar question as of union. So instead of union, now we are talking about intersection. So again we define the range for cardinality of intersection. So we look at the extreme case. So extreme case, one scenario is when they don't have any common element. Set A and set B have no common element. There is nothing common between them. No common element. So what will be the intersection? It's obvious. Their intersection will be empty set. There is nothing common. So what will be the size? Size is going to be 0. So and the other extreme case, one set is completely contained in the other set. Suppose A is less than B. So all elements of A are inside B. So all elements of A are contained in B. A's all elements are contained in B. So what will be the size of intersection? Common elements of A, because these are contained in B. So all elements of A are there in set B. So A intersection B, it will be simply the set B. Sorry, the set A, because A is smaller. Set A. So in cardinality of B is going to be cardinality of A, which is M. So we define a range. What will be the range of A intersection B? It is greater than 0 and it's less than minimum among A and B size. Minimum among M and N. Fine. So this is question number 5. Okay, thank you.
What card?